Well, thank you everyone for coming. My name is Wei Zhou. I'm the head of AI utility research at SemiAnalysis. We're like a research firm and popular blog. Do a little bit of everything, but have really kind of done a full analysis of the industry from wafers all the way down to tokens. And I want to introduce our panelists today, starting with Thomas from Supermicro.
Thank you. Great to be here.
Then we have
fans in the room.
yeah, we have fans in the room. No Wei fans. And then Eric from Zephyra.
Hello.
And then we have Ted from AMD.
Nice to meet you. Bringing the goods.
Yeah, we failed to we didn't get the Hawaiian shirt notification, but next time. Yeah, I think we wanted to start off talking about kind of like a little bit of the history or evolution of AI deployments from the hardware, and then go down to the model layer. So I don't know who wants to start off, but maybe Thomas, you want to talk a little bit about kind of how we got here and how Supermicro has kind of pioneered some of the designs and deployments that we see today.
Absolutely, and thanks for the question. Yeah, Supermicro has been in the business of delivering building block solutions for servers, then for racks, then for clusters, and now for complete data centers. So we started off 32 years ago with simple motherboards. Today we deliver complete AI factories or complete AI clusters, and including everything around them. Everything between the dirt and the token we can deliver today. And that means our newest and latest and greatest is what we call data center building block solutions, which is what we used to build and cobble together the AI clusters with power, with cooling, with everything you need, with connectivity. So today from Supermicro, when you buy a liquid cool cluster, we deliver everything. We're one-stop shop in a sense. We're the one throat to choke if there's a problem anywhere, right? From cooling to CPUs and GPUs. Obviously, we use AMD and other brands of GPUs and CPUs from AMD and Intel, but we have seen AMD on a roll, particularly in the data center in the last couple of years. And I think they're close to being #1 in the data center now, which is an amazing achievement, which we're very proud of here and being part of helping them. But together, Supermicro works with our partners. We create clusters, we create the solutions. I think we can crank around 5,000 racks out per month today, which is many data centers every week. And it's not just the servers themselves, it's the design, the topology of the network, so we can run optimal speeds when a customer takes delivery of their GPU cluster. We guarantee the performance and we guarantee the uptime, and it's something we do every day. We can roll out very large data centers in very short time.
Actually, it's a good point in terms of partnering with upstream, because I feel like this AI revolution is like the first time you're seeing everything matters, right? It's like you kind of have to consider the power, the cooling, the chip design, and how you're going to take this chips from just being 8 in a rack to multiple racks connected. Ted, I'd love to hear from you in terms of how AMD has kind of developed this data center business, right? From just selling kind of EPYC server chips to now selling whole systems, and how working with Supermicro has been for that journey for the chip company.
Yeah, happy to elaborate further. I think, the one thing that I like to just sort of put out there to start with is with where we are with AI, a lot of people, there's constant talk about, is it a bubble? Is it like going to crash, et cetera? And I think what's really interesting about where we are today is that this is really the first technology that I have ever known where it hasn't started in like university and government, military. It's, usually that's how compute started. It was too expensive. They were used there. Then enterprises used it. Then the cost came down and consumers used it. And that's how networking went and all the other technologies. But AI is different, right? It's like, it's all of us who are, started using it almost immediately after the Chat GPT moment, right? Just a couple of years ago. And so, now people are like, oh, create a video of my cat, surfing or whatever, right? And so it's like all this demand, and now all of a sudden you have these sovereign clouds coming because nations want it, enterprises want it, and so on. And from AMD's perspective, 6-7 years ago, they got into the server CPU business. We had 0% market share, and today it's the de facto standard, generation after generation. It's the best performance CPU, and the organization's been working super hard in the GPU group, which I'm a part of. We have been creating our Instinct GPUs and really delivering amazing performance at a great TCO with an open architecture and open ecosystem. And that's really what we're super focused on. And we're really the only alternative to Nvidia in the market, and we're here to deliver. So I'm really excited to be part of the panel, and that's kind of my 10,000-foot view.
Yeah, actually, so speaking of TCO, just short plug, SemiAnalysis, we do a lot of research kind of looking at the economics of AI, right? And I think one thing that, is a bit of a like a mystery or kind of dark arts is, how are these tokens created and how efficient are hardware creating tokens? And I think, one thing we just launched recently, which is this benchmark called Inference Max, literally measures on nightly runs the productivity of GPUs in producing tokens across a wide array of what we like to call user interactivity, like user experiences, right? And I think people will be kind of surprised to see that like AMD is extremely competitive on like some of the most used models today, like GPT OSS 120B. Super efficient, very, very good bang for the buck, because the software stack is developed, and then you also have like a model size that fits well with the high amount of memory that you get in each Instinct GPU, which actually leads me nicely to my next part of the question. Eric, I'd love to hear from you in terms of how you've seen the hardware evolve and how the different vendors have been able to enable, model trainers and model developers like you guys to do your job better and offer, alternatives to Nvidia.
Right. I've been to the hardware side before I joined Zephyra, so this background across big tech. And in Zephyr, of course, our main focus is super intelligence. We are an AI company. We create foundation models from scratch with pre-training, multimodal. We create enterprise agents, and we innovate on the model architecture. We go beyond the transformer. And right, and we are pleased, of course, with the hardware, the platform. We are using an Nvidia for most of research, because it's bells and whistles of flexibility. But for production pre-training, we really work using AMD because production pre-training is very costly, and it's not a problem having one or two more engineers helping setting it up right, and then we can run pre-training on AMD very well in a large scale. And I think the whole field is evolving fast on the hardware side. So the infrastructure is getting better and better. We can do much more. So it's we have AMD as alternative, and yeah.
Yeah, I guess when we think about large language models, the emphasis is on large, right? Like trillions and trillions of parameters, huge models, huge runs. I'd be curious, like, from Zephyra's perspective, where do you see the world going in terms of open source models and maybe some of these smaller models that people are developing? Like, do you think they're like a viable path to, more intelligent tokens or like better business outcomes for people that implement these models? Like, how do you think about kind of the diversity of models that we see being developed in the world today?
Right, of course, the future, we have large models, medium models, small models. Open source definitely helps in general, because with open source models, people can better integrate them and change them and run them where they want to run. And we are an open source company, so we create our models are mostly open source. And right, and yes. Mm-hmm.
Well, how about that? What have been the challenges of scaling the model in terms of pre-training runs, right? Because my understanding is, even for like a 50 or 70 billion parameter model, you might not be able to fit it all on one node. I'm just curious, like, how do you guys think about that? And how has AMD been to work with as a partner?
Right, exactly. So so far we've used H100s before. We switched to MI300X with the AMD and IBM partnership, and this helps a lot because we have twice the memory, right? Twice the bandwidth. So scaling using AMD is particularly we have mid-sized models, MOEs. They fit very well on GPUs. So it simplifies our scaling a lot. We can run a lot on single GPUs, but of course we do data parallelism across GPUs. And then of course, but for larger models, right, we have to split it. Use one of these standard frameworks to distribute training on AMD.
Mm-hmm. And we've been relentlessly investing in software resources like the RCCL, our ROCm Collective Communication Library, right? Just to make these larger clusters more efficient and optimize the models further. So our ecosystem is all about attracting developers, attracting third parties. If you're not aware, earlier this year, we announced a developer cloud where people can sign up super easy on AMD's site and get access to a free node, and you can do development, and definitely want to encourage more people to do that so we can accelerate the innovation cycle for AI for all.
Actually, Thomas, maybe coming back to you, I think one thing that we've seen is there's the market's moving so quickly in terms of hardware and software developments. You have a lot of customers, like these kind of neoclouds are starting these new businesses trying to rent out GPUs or find AI customers, but they all have, let's just say, varying degrees of experience running these clouds. Like how does Supermicro help like these new customers? How do you guys work with these neoclouds in terms of helping them build something that's enterprise or production grade?
Well, it starts with assisting them in really developing the idea they have, right? And neoclouds, as we see them, there's different focuses and different areas they go into. But what we try to help is make sure that the design of the clusters of the data center itself supports the business model they have. And it's not just hardware, it's also the design of the cluster, topologies, storage, this whole AI data platform that is beginning to take hold as well, with some of the big software-defined storage vendors that we work with. These are some of the things. We also have developed, I don't know if you know it, Supermicro is a hardware company, but we actually have 1,200 software developers, and most people don't know that. Some of these people are actually making really cool things. One of them is a GPU as a service software suite that works in conjunction with our SuperCloud Composer, so you can actually effectively render out either bare bones or GPUs, and it includes billing and the whole thing. And we are now selling that to neoclouds, and it helps them get to market much faster because you don't have to develop all these things yourself. So it's part of those building blocks we now have that can accelerate the growth. This whole data center building block solutions we're talking about was built as part of reducing the time to online, right? Because there are certain places in the world, if you need a new transformer, there's a 4-year wait time, right? Because these are old school businesses, old industries, and they don't move at the speed the IT industry does, or AI. So we have started developing a lot of the components around the data center that can reduce the time to online. So how do we unlock more data centers? We help people build them faster. We make sure that those components that have extremely long lead time, they can get that in a couple of weeks. We can install a cooling tower now in a month, right? That's something people have been waiting years to do in other places. So those are the kind of things where we can accelerate the support for these neoclouds.
Yeah, I think one of the, kind of not dark secrets, but let's just say like undercovered aspects of the industry is, a lot of these GPUs don't run 100% of the time as advertised, right? There's a lot of issues that come up, backplane issues, networking issues, connectivity issues. These are things that Eric probably faces when he has to SSH into these clusters. But like, I'm curious, how do you see, some of your customers dealing with these issues? Is there a clear difference in performance between certain hardware vendors? Like, what are the main challenges you think Supermicro or even AMD can help these new customers solve in terms of running a productive and high throughput AI factory?
So we have a number of partners.
Ted
I'm
is like
sorry.
salivating. He's like, I want to take this
Ted,
one.
go.
No, what I would say is that we do work with partners like Supermicro is really great about. For example, you can order a 16-node cluster and have them test it, right? So they fully set it up, run a number of tests before that gets shipped out. As a company, we're constantly striving to, on a regular basis, continue to enhance and improve not only the performance, but the reliability, right? A lot of firmware updates. There's many things that we're doing on a regular basis to improve these architectures. I mean, I think what most people don't understand is you have these 8 honking GPUs, right? That are, drawing, more than a kilowatt each, right? Just that alone is mind blowing. And then it's, connected to 2 CPUs. Then you have a bunch of networking cards to connect them all together. It's a very complicated and a complex system. And, even though it's silicon and it's each individual component's very reliable, because there's so much to the system, right? There's going to be challenges. And, we work with partners like Supermicro. How can we, make the RMA less painful? There's many things that we're doing because we know that customers need to stay up. They need to be running, and that's kind of really the key. So we're really focused on that and trying to help partners, especially like Supermicro.
Back to me then. Well, now would be a perfect time to plug SemiAnalysis' Cluster Max benchmark. But actually, it's interesting. So, like, Eric, I would be curious. Have you looked at the benchmark? It's basically, for those that don't know, it's it basically reenacts a user's experience for renting out bare metal or VM clusters. And this is, there's a very small portion of the world that does this, right? Because you're running AI models and not everyone knows how to do this. But there's all these little technical snafus and details that go into renting a cluster that's very different from traditional, cloud, right? You spin up a hypervisor or whatever, you're in a container. I'm just curious, like, how do you think about, like, services like Cluster Max, or how do you even try to evaluate the quality of different neoclouds as a potential partner?
Yes, I think these benchmarks are very, very useful. We are very glad you guys spent all the effort. It's a lot of effort to create these benchmarks. And I was reading the documents, I was looking into it, and it's very helpful to get some idea on where the performance is and what is the right platform for our use cases. So it gives some very, very good idea on where things are. Because of course, the real flop numbers don't say too much. That's very, very useful.
It's a really good point. Not all flops are built equally, right? And just like not all, GPU dollars per hour are built equally. Ted, what would you say to customers when they come to you and say, look, why would I rent, AMD for X dollars when I can get Nvidia for X plus 20 cents? Or, what's your kind of pushback to that?
Yeah, I think there's a couple of key benefits that we're bringing to the market. Number one is just an alternative, right? So a lot of the customers, understand there's a significant amount of spend that they're just putting all their eggs in one basket, if you will. So, AMD has a very compelling alternative from a performance, from a TCO advantage. And in addition, our architecture is open, right? We really strive and are pushing Ethernet to be kind of de facto and driving Ultra Ethernet as well as a next generation standard for even lower latency across the network. And all of these things are basically allowing innovation to happen and also allowing freedom of choice. So those are the messages. Those are what's key is like you're getting excellent performance, you're getting it at a better cost structure, and you're getting an open architecture that you can innovate on and allow flexibility as you move forward.
Yeah, I think something that's maybe not spoken as much is, just like how Nvidia is scaling from the HGX, MGX platform to the NVL72 world size, AMD is actually on the cusp of that next year as well, right? So
Yep.
I think, it's kind of really interesting for customers right now to build on AMD because soon, you guys will have the only, x86 power 72 world size GPU node. Can you give us some preview on what, how are people thinking about Helios? How are people thinking about this new rack structure? What are the innovations that you think will drive customer adoption? And what are you guys going to do different than NVIDIA?
Yeah, Wei, I think you already, if any of you have seen any news from AMD and our GPUs in the last 3 weeks, you've seen these major, huge announcements, right, of companies that are going to adopt in a massive way AMD GPUs, right? So it started with the OpenAI announcement, which is a 6 gigawatt. And I remember when I read this is kind of a funny story. I remember reading it and I get this internal email. It's from Lisa Su, and it's like, oh, OpenAI, and I when I first read it, I was like 6 megawatts. I'm like, gee, that's not a big deal. Like, what's the big deal here? And then I like reread it. I'm thinking to myself, she wouldn't have just sent it out if it was that. And then it was like 6 gigawatts. And then the first thing that comes to my mind is, that's like a gigawatt. Like, we're going back to the future and like all this stuff. But in reality, when you do the math, if you assume one GPU is 1 kilowatt, and then you just do the math into 6 gigawatts, what that number is, and then it's just like, oh my God. And I remember texting my wife saying, well, this is going to be great news for the stock. So the OpenAI thing was tremendous. We were awarded a Department of Energy, not only one short-term cluster, but a next generation as well, OCI as well. And if any of you were at OCP, you actually saw our next generation rack. So there's a new wider rack standard that AMD was integral in driving. And again, it's a standard, so anybody can use it. And we were super fortunate. Our location was right across from where Meta was. They literally had a rack, same type of architecture. It was a little bit different configuration than we had. But I mean, you can see that a lot of these customers are putting significant resources into AMD because they want the balance. And we're here to deliver that. We're on a breakneck execution pace, and that's just what you're going to continue to see from us, and you should expect from us. That's what we're going to deliver.
And I think it would, you mentioned a little bit earlier, but like just the hardware innovation is really important, but I think it understates the software improvements that you guys have made over the last 6 to 9 months. Because I like, for those not super familiar with SemiAnalysis, in December we wrote a fairly inflammatory article describing how poor the ROCm experience was. I'm actually curious. This is probably the first time asking you this, but like, how did that affect the company? How did that, did it depress you guys? Did it make you guys want to work harder? Have you noticed a tangible change in terms of the investments that AMD's been making in the software stack since that article?
Oh, yeah. I mean, massive way. So, I don't like, it's not like I took a survey when that came out, but, anecdotally, there was frustration, but there was also, we knew that there was so many things that we were investing in. We knew we were doing all kinds of, we were doing the right things, and it just, these things take time, right? It doesn't happen overnight. So if you're not familiar, we've made several acquisitions of different software companies, probably the biggest being Silo.ai, and there'll be an announcement coming out in a week or two on something which the enterprise market will be really happy to hear about. So previews, coming attractions there. But what I will tell you is, when I started at the company just over 2 years ago, someone would come on and, we'd kind of go like this and hope that it was going to run or compile. And sometimes, the results were, whatever, 70% or 50% or didn't work. And, I could see every quarter it was getting better and better. And, as we rolled into 25, now, all of a sudden, people were taking a workload, trying it, and one of the things I worked really hard with in Supermicro is they have a lot of remote nodes. So you can use 350, 355, you can get 300, whatever, you can get access to these and, run your workload. And we definitely encourage people to do that, because the results now are extremely promising. People have moved over. It's like super close, and they haven't even optimized for our architecture. So I do, in a backhanded way, thanks for helping push it a little further. We were already doing a lot of those things, but I always feel like as an organization, we want to deliver the best experience possible. And right now, it's just about prioritizing.
Yeah, people backhand us all the time. It's great. No, but actually, speaking of measurable, we did launch this benchmark with the partnership of Nvidia and AMD, and these are basically nightly runs of token throughput and the implied cost per million tokens across AMD and Nvidia hardware. And yeah, I think if we ran this benchmark, 12 months ago, it would have probably looked very, very different. But given all the work and optimization from both companies, frankly, right, it's very, very competitive on these models. And yeah, we hope to continue that collaboration and make it super transparent to everyone. The analogy I like to give for people that aren't super familiar with like tokenomics or the economics of these AI factories is, back in the day, if you play video games, right, what you really cared about was frames per second, right? Like how fast is my GPU delivering frames per second? Because anything below 25 and you would notice it. And what we basically launched is the frames per second equivalent of token production, right? We're looking at the tokens per GPU per second. But just like the old days with video game benchmarks, the bigger your screen resolution, or the more filtering you put in, or the more shading you put in, the more complex the workload, and therefore the more impact on your frames per second, right? So I think it's really important for people to understand, like, a token isn't the same across all models, and the productivity of a given piece of hardware really depends on how fast you're serving that token per user. And so it's a really cool benchmark, Inference Max. It's a really cool way to explore the economics of AI and, kind of really bring home the idea from data center or chips all the way down to tokens. I think we wanted to do some audience questions, right? So I'm curious if you guys want to just open it up, or... Yes. Or I'll repeat it.
Okay, so this is a question for Thomas. So you talked about this GPU as a service. You're saying helping people get up to speed and faster to market. Are you providing the blueprint, or are you actually providing the entire components that needs to get out to be able to create that as a solution?
So the question was for Thomas, when Supermicro is talking about providing GPU as a service, are you providing the blueprint or the whole go-to-market? Or basically, what's the extent of the...
What we're providing is not GPU as a service, right? That's what our customers provide. So we provide the clusters for that, the data centers for that, the GPUs, networking, the whole thing. And then we've added a piece of software that allows neoclouds to get into business very fast. And that means they will get a system that can provision and provide access to the neoclouds customers for the GPUs of the bare bones, and it includes the billing and the whole thing. It's like your operating system for a neocloud. And we're selling this as a solution to our customers. We're not providing GPU as a service, right? We're selling the materials you need to create that. And if you want to know more, hit us up, and we're happy to connect you with the right PM to show you more about that.
I would add on to his question. It seems like a very interesting product. What kind of uptake you have from neoclouds that would use this? And specifically, is the idea to have an open marketplace around this as well?
These are we opening a neocloud app store? No, not yet. but let's see what the future brings, right? This is the first step in providing some of those software platforms, but I'm sure our software PMs could expand it into include something like that. But it's not something that I currently know about, so I'm not going to comment on it.
Now, just to speak up, there's 3 cloud vendors here that have instances of Instinct. So Vultr, TensorWave, and Crusoe. So like there may be some insight that they could give you because they've deployed and utilized Supermicro and AMD's products.
All very highly rated on SemiAnalysis clustermax.ai rating, which you should check out.
Yeah.
One thing I wanted to expand on, and thanks Ted for mentioning it, if somebody is interested in trying these AMD servers, MI350, MI355, and the others, we do have a number of them available for POCs. We have some of the experts in the room actually, and at this event that can hook you up with that and explain how it functions. But basically, it allows you to get in and play around with it and see the ultra high performance you actually can get out of these beautiful AMD systems. So if you're interested, let us know, and we can hook you up on it.
We're going to get you the mic. We'll do it right this time.
Maybe a question both for AMD and Supermicro. With the rapid innovation, right? How do you guys keep up with all the roadmap changes? It's probably every 6 months, 1 year, you come up with new products, right? And how are the neo clouds and the hyperscalers, consuming that? It's a good thing, but it's also, causes a lot of turmoil in the market, right?
Yeah, that's a good question. And I think that the market has transitioned over the last couple of years where it was kind of on an 18-month or so cadence of new product introductions. And now the customers are really demanding a yearly cadence. And that's caused AMD to have to make a lot of changes. And, all the supply chain, in fact, has had to adapt to that. And it's not easy to deal with. Of course, the previous product that we had sell, the 325, you can still buy that today, even though that product's just over a year old. And so we're delivering because of the market demand at a yearly cadence. Is it easy to deal with? No, it's not. For the cloud vendors, for our partners, and for the entire supply chain.
Yeah, we've changed from roadmap meetings every 6 months to bi-weekly now. It's an insane pace, right? But I think there's something to be said for also not necessarily having that fear of missing out, having the latest and the greatest at all times, right? We have customers perfectly happy running on GPUs that are even years old. They still work, and they still work fine, right? Depending on what you actually need. Let's help find the right solution. It doesn't necessarily have to be the one that came out next week, right? So sometimes it's smart also to sit back and figure out what exactly do you need, and let's find the most optimal solution.
Hi, this is sort of your way, particularly for you, because you look at all of this in the financial metrics. Data centers used to be depreciated over 10 years, different parts over 5 to 7 years, particularly the processors, about 5 years. That has now shrunk to probably 1/3 of its rate, give or take, maybe 5 years, and GPUs at the rate of about 2.5, 3 years. How do you see the economics recover? Because eventually these have to become profitable ventures, right? Spending $1 trillion and losing another $2 trillion on top of it is not the process. So what's the...
Yeah, we get this question a lot. So I would say just to level set, there's a lot of different parts of the data center that get depreciated at different rates, right? So the co-location equipment, the cooling, the power, switchgear, things like that, 10 to 15 years, depends on what it is. And sometimes that's a little conservative, as in the equipment can last longer. I think right now, as you see a lot of innovation in cooling and maybe power requirements, maybe that could be shorter, but it's not necessarily to me that the equipment will fail in a shorter amount of time. It might be the fact that you need to refresh the equipment faster. CPUs, server storage, it's a good question. I think historically the depreciation schedule for those started off shorter, like 3 to 5 years, and then the hyperscalers and the people that operate these at scale have been lengthening it every year because they found that AMD, EPYC, CPUs last longer than 3 years. I can't help but plug, Anyways, but I think with GPUs we're kind of still filling it out, right? As you heard, Thomas talked about, like there are people still inferencing on A100s, especially for smaller models. A fully depreciated A100 is extremely efficient, right? I think the way to think about it is like the early days of semiconductors, right? You had lagging edge foundry wasn't really a thing because people moved nodes really quickly. But today there's a huge portion of the market that produces on 28 nanometer and above because it's super economic. There's no real innovation curve to shrinking the nodes. And like, you know, an automotive up down, you know, chip for moving the windows is perfectly fine at 28 nanometers or above. So today, the economic return is still quite positive for GPUs. People are renting them out, committing to anywhere from 5 to 7 year deals, and generally even on an aggressive depreciation schedule, you're more than covering the purchase plus electricity plus your cost of capital, even on a like 4 year depreciation with the deals that people are signing today. That may change in the future. You know, there might be price competition to compete the lease rates down, but the way we see it right now, almost all of these deals being struck are in the money. The bigger picture question I think that you asked and a lot of people are asking is, you know, where does the buck stop, right? So this might be a very profitable business for AWS or Microsoft or Oracle or all the neo clouds I haven't mentioned, but you know, what about the end customer? And I think that's a it's a bit of a philosophical question these days. But on the other hand, these are the fastest scaling businesses on ARR that we've ever seen in the history of Earth, and so it's a bit of a bet that, you know, essentially the supply of compute creates demand for compute that translates into dollars. But yeah, a lot of people ask about like the durability of GPUs and how long you can depreciate them. I would say, you know, barring an actual catastrophic failure event where like 50% just like die, there's actually there's a pretty long tail of models that use older GPUs efficiently, especially smaller models.
I think we're out of time.
Good question to end it.
Oh,
5 minutes
5 minutes? Okay, another question.
by popular demand.
Yeah. He had raised. I just saw the 0 there.
So I have a question for Ted. As AI models expand into global markets, how does AMD see the role of culturally aligned datasets and improving model performance on AMD hardware?
Can you repeat that? I got about 2/3 of what you said.
So as AI models expand into global markets, how does AMD see the role of culturally aligned data sets, improving model performance on AMD hardware?
That might be an Eric question.
Well, yeah. I mean, I'll give you a brief answer, and you can probably go too. So there's a you know, a massive push by a lot of sovereign or countries because they want data in their area, region, if you will. We're working with a lot of these clusters and different organizations to basically introduce and architect clusters that make sense for all these different countries and regions. We're working with, and again, because we have our ecosystem is open, not just from like an Ethernet and networking and so on, but from a software as well. So we're working with a lot of different third parties across the globe to provide and to enable the local data formats and those models that are in those regions to flourish on Instinct hardware.
And since we are creating custom models, we of course can pick data from different areas, locations, and countries to create custom models from that domain, from that area. So we create custom models, and we can pick the data set which makes sense for the region and for what problem we want to solve.
Someone have the mic?
Dwayne.
Right over, right here.
Thank you. As we see the power density of these racks over the next couple of years getting upwards to a megawatt, are we going to see 100 megawatt data centers compressed down to, let's say, an acre? Are we going to see just a very different footprint versus historically how data centers have been built?
Yeah, that's something that a lot of our customers struggle with every day, right? We are now seeing in the roadmaps of both AMD and Nvidia, extremely high density GPUs in single racks. So yes, a megawatt rack is absolutely on the horizon right now. We actually have several customers who are working and developing data centers that will come online in the next 12 to 18 months. And they are targeting 1 megawatt per rack, right? So it's not a question of if, it's when. So it will happen. But again, we always have to look at what is the usage of those, right? We are looking at the companies developing frontier models and you know, running very, very, very large inferencing solutions. So not every rack will be a 1 megawatt, right? There's going to be plenty of rack that can run at 50 kilowatt with 4 servers and still do extremely well. We also have to remember that most data centers in this world are not ready for that. Liquid cooled and power delivery at that kind of scale is not even 1 or 2% of the world's data centers today, right? So it will be a gradual build out. So brand new data centers, greenfield data centers, yes, they will look at that they look in the crystal ball and they invest according to what they believe. But absolutely, 1 megawatt is coming, and you know, you can count the number of racks that they're going to have.
The only other thing I'll just add is if you take a look at our Helios rack, one of the reasons we went double wide was to actually address that exact concern, right? Because it's so hard to have significant power per rack. So actually, there's a lot of advantages to going wider, which are not very intuitive, and happy to follow up and talk about that after.
Yeah. Another one is sidecars. We are seeing power racks coming online, changing the way power delivery is being done to servers. If you follow what OCP is working on and proposing, you will see a change in power delivery that's going to make concentrating power in a few racks and then supporting many racks of servers. So there's a lot of development on the way right now that will address some of those issues.
Well, I know you don't hear it yet, but the Oscars exit music is indeed playing in the background. So I'd like to thank everyone. Thomas, Eric, Ted, thank you so much for your time. Thank you everyone for your questions.